All right, today we're pulling back the curtain on the internet's invisible architecture. We're going to dive into the master plan that makes sure every single email, video, and message you send arrives exactly where it's supposed to, perfectly intact. Let's get into the OSI model. I mean, seriously, think about it. It feels like pure magic, right? You hit send on your laptop, and just seconds later, your message pops up on a totally different device, maybe thousands of miles away. How does all that data not just turn into a scrambled digital mess? Well, that's the exact mystery we're solving today.
The solution, believe it or not, is basically a universal translator for all of our gadgets. It's a standard set of rules, a common ground, that ensures every device is speaking the same digital language.
So here it is, the OSI model. You can think of it as a blueprint for communication. It was developed by the International Organization for Standardization, the ISO, to make sure that a computer made by one company could talk flawlessly to a server made by a completely different one. It created a standard framework so that everything could just work together. Now, this blueprint isn't just one giant complicated rulebook. Oh no, it's much smarter than that. It's broken down into 7 distinct layers, and each layer has its own specific job to do. This whole thing is what we call the OSI stack. So what are these layers? Here we go, the 7 layers, starting from the top where you are and going all the way down to the physical wire. We've got application, presentation, session, transport, network, data link, and finally, physical. Now, if you want a handy way to remember them, just think of the phrase, all people seem to need data processing. Kind of works, right? So when you send something, your data starts at the top and makes its way all the way down this stack. To really get a grip on this, the best way is to actually follow a piece of data on its journey. Let's watch it travel down through all these layers. This is where it all starts to click. So let's go back to our email. You're person A, and you're sending a message to your friend, person B. You've typed it all out, you've hit send, and that one single click kicks off this entire 7-layer chain reaction. Okay, these top 3 layers are all about prepping your message for its big trip. At layer 7, the application layer, that's you, using your email client. Simple enough. Then your data hits layer 6, the presentation layer. This part is like a translator and a security guard rolled into one. It makes sure the data is in the right format, compresses it to save space, and encrypts it for safety. Right after that, layer 5, the session layer, opens up a direct line of communication with the person you're emailing. It basically says, hey, are you ready to receive some data? And manages that connection. Now we get to the logistics. Think of this as the digital post office. At layer 4, the transport layer, your nice big email gets chopped up into smaller, more manageable chunks called segments, and each one gets a number. Then at layer 3, the network layer, each of those little segments gets put into a digital envelope called a packet. And on that envelope, it slaps the final destination, the IP address. This is exactly like putting the street address on a letter. So you might be asking, why on earth would you chop up a perfectly good email? Well, it's actually genius. For one, if one tiny piece gets lost on the internet, you only have to resend that one tiny piece, not the whole thing. And 2, those sequence numbers are crucial. They allow the computer on the other end to put all the pieces back together in the exact right order so the email looks just like it did when you sent it. And that brings us to routing. This is the main job of layer 3. With that IP address stamped on the packet, the network layer acts like a super sophisticated GPS. It looks at the entire map of the internet and figures out the absolute best, most efficient path for your data to take to get to its final destination. And finally, we're down at the hardware level. We're almost there. At layer 2, the data link layer, each packet gets one last wrapper called a frame. This frame has something called a MAC address. Think of this as the address for the very next stop on the journey, like your home router. It's for local delivery. Then we hit the bottom, layer 1, the physical layer. This is where all that data gets converted into actual physical signals, electrical pulses down an Ethernet cable, flashes of light in a fiber optic line, or radio waves for your Wi-Fi. So let's recap that wild downward journey. Your message starts as plain old data. It gets broken into segments, which are then placed into packets. Those packets get put into frames, and finally, the frames are turned into bits. At every single step, a new layer of info gets added on. This whole process is called encapsulation. It's like your data is getting dressed in more and more layers of clothing for its trip across the internet. Okay, so your data has been sent. It's out there, traveling the world as bits and bytes. But what happens when it gets to person B's phone or computer? Well, as you can probably guess, the whole thing just happens in reverse. The bits arrive at the physical layer and get turned back into frames. The data link layer checks the frame and says, "Yep, this is for me," and passes the packet up. The network layer checks the IP address and passes the segment up. The transport layer takes all those numbered segments and puts them back together into the original email. And it keeps going, unwrapping each layer all the way back up the stack until voila, your email appears perfectly formatted in your friend's inbox. It's a really beautiful, symmetrical process. Now, you might be thinking, this is cool and all, but how relevant is a model from the 80s today? And that is a totally fair question. So let's talk about why the OSI model is still so incredibly important.
This table is a fantastic cheat sheet. I want you to look at that middle column, the Protocol Data Unit, or PDU. That's the special name for your data at each specific layer. It starts as data, becomes a segment, then a packet, and so on. It perfectly maps out the journey and the main job of each layer, from the user interface you interact with at layer 7 all the way down to the raw signal transmission at layer 1.
So here's the bottom line. The internet today doesn't strictly follow the OSI model step for step. It actually uses a more streamlined model called TCP/IP. But, and this is a huge but, the OSI model is still the absolute best tool we have for learning and understanding how networks work. It gives everyone a common language, and for engineers, it's a lifesaver for troubleshooting. When your internet goes out, they can literally ask, is it a layer 1 problem, like a bad cable, or a layer 3 problem, like a bad IP address? It gives them a logical roadmap to find and fix the issue. So the next time you send an email, stream a movie, or just scroll through your feed, take a second. Try to picture your data being wrapped up in all those layers, flying across the globe as a stream of ones and zeros, and then being carefully unwrapped at its destination. It's not magic, but it's pretty darn close. It's the elegant, invisible dance that powers our entire connected world.